Hi everyone, I am Dr. K. from the Department of Civil Engineering. Today we will delve into the fundamental aspect of surveying in our session on angular measurement. While the title emphasizes angles, our focus will expand to cover the essential principle of leveling, which is crucial for determining elevation and understanding terrains. Thank you for joining me. To guide us the today's discussion, we will cover the several key areas. We will start with the introduction to leveling, understanding its core purpose. We will then examine the dumpy level and other types of level used in the field. This will be followed by the crucial concepts, the height of collimation. We will define the differentiate between the foresight, backside, and intermediate site. We will then walk through the leveling procedure itself. Finally, we will explore how these principles are applied through the concept of contouring in surveying. Let's begin by defining the leveling. It is a fundamental branch of surveying whose primary object is to determine the elevation of a given point with respect to known as a assumed datum, which is a fixed reference point. In simpler terms, it is the process of finding how much higher or lower on one point is compared to the another. Common instruments that makes this possible include the split level, the dumpy level, and the digital level and the model laser level. To understand the leveling, we must grasp some key definitions. A level surface is a curved surface that is at every point perpendicular to the direction of gravity. The surface of a still body of water is a perfect example. Any line lying on the surface is called a level line. A horizontal plane through the point, on the other hand, is a plane that is tangential to the level surface at the specific point. It is perpendicular to the plumb line on the locations. One of the most traditional and reliable instruments is the dumpy level. The name dumpy means short or thick, which describes its compact and stable design. Its key features is that the telescope is rigidly fixed to its supports and cannot be rotated about its longitudinal axis. A long bubble tube it has attached on the top of the telescope, which is used to precise leveling instrument. Um, Next one is the laser level. Moving to modern technology, we have the laser level. This instruments radiates a laser beam around 360 degrees through its line of collimations. This beam is then detected by a receiver, which clearly indicates the level line. Many modern lasers are self-leveling. Survey quality laser level are characterized by whether the beam is visible or non-visible, or whether it is rotating or non-rotating, making them highly efficient for certain tasks. Next one is the automatic level. Automatic level is perhaps the most commonly used instruments today due to its ease of use. It only needs to be set up roughly level within the circular bubble. Its key components is an internal damping compensator that automatically adjusts the line of sight to be perfectly horizontal, achieving accuracy typically within plus or minus 2 mm. This makes it both robust and high accurate for general surveying work. Despite advancement instruments, understanding potential errors is critical. While these are many sources of errors, especially in precise long distance leveling for most common projects, four are particularly worth noting. Errors from the instruments maladjustment, the staff not being vertically held, errors in reading the staff, and natural effect like refraction. Being aware of this helps in minimizing their impacts. Now let us understand the specific reading. We take the backside, or we call it as BS. In the staff reading taken after setting up the instrument, it is always taken on a point of known elevation like a benchmark. This reading is used to calculate the height of instrument, which is the elevation of the line of sight of the level. Next one is the intermediate level. Any intermediate site or IS is any staff reading taken after the back reading but before the foresight, that we call it as the intermediate site. These readings are taken on the point whose elevations we need to determine. It is important to note that intermediate site do not change the height of instrument. They are used only to calculate the reduced level for that specific point using the already established height of instrument. Finally, we can see the foresight. The foresight is the last reading taken from a particular instrument setup. It is taken on a change point, which is a stable point that will becomes the new reference for the next instrument setup. This instrument's reading is used to determine the elevation of the change point, which then allows us to carry the level forward when we move the instruments to a new locations. The height of instrument method is the standard leveling procedure. First, we set up the level and take a backside on a benchmark. We can calculate the height of instruments by adding BS reading to the known reduced level of the benchmark. Next, we take the intermediate sites on various points. The RL of the each point is found by subtracting the IS and height of instrument. Finally, before moving the instruments, we take the foresight on a change point. The RL of the change point in height of instrument minus foresight. This RL becomes the new known values for the next setup. Assumptions. All leveling calculations are based on the four fundamental assumptions. First, we assume the line of sight is perfectly horizontal when the instrument's bubble is centered. Second, we assume the plumb line indicates the true vertical. Third, oversight distance, and we treat the earth surface as a level surface, ignoring curvature. And the fourth, we assume the leveling staff and is held perfectly. Limitations. Leveling, while powerful, has its limitation, and instrumental limitations includes the need for perfectly adjusted instruments. Even a small or errors on the line of collimations can cause a significantly error or over distance. These instruments are also sensitive and require careful handling. Finally, the data we gather through leveling is often used to create contours. A contour is an imaginary line on a ground that connects points of equal elevation. When drawn on the map, this line provides a powerful visual representation on the terrain, topography, and a relief showing us the shape of the land. Contour have specific characteristics that makes them interpretably all points on a signal contour lining having the same elevation contour lines never crosses over or intersects each other except in the rare case of an overhang cliff. These uses of contours are extensive in civil engineering. There are essential preparing topographic map, which forms the base of for planning. Engineering use them to select site for dams, roads, canals, etc. To determine intervisibility between 2 points for setting up communication towers, to calculate earthwork volume for cut and fill, and to design effective drainage and irrigation systems. There are various types of contours. While this slide simply mention types, it's important to know that contour can be categorized based on the how they are derived. Index contours are bolded and labeled with their elevations for easy reading. Intermediate contour are fainter lines between them. Supplementary contours are sometimes used in various flat terrains and shows minor variations. The specific interval between contours is chosen based on the steepness of the terrain and the purpose of the map. This concludes our overview of leveling and its crucial role in understanding the elevation and terrain through the angular measurement and beyond. These principles are the foundation upon which safe and efficient infrastructures is built. Thank you for your attention. Thank you.